There's a giant hiding in the middle of our galaxy right now. It is millions of times heavier than the Sun. It has been sitting there this whole time, quiet and mostly invisible, while billions of stars spin around it like they are stuck in a slow dance they can never stop. And here's the wild part. Almost every galaxy in the universe has one of these giants at its center. Some of them are so heavy that if you tried to write out their weight in suns, you would run out of room on the page. Scientists have even found some that are 1 billion times heavier than our Sun. One of them might be pushing close to 60 billion times heavier. So how does something we cannot even see get that big? And what happens to a galaxy when the monster in its heart keeps eating and eating? Stick around, because by the end of this video, you will know why some scientists think this giant might even decide whether life like us gets to exist at all. The invisible giant. Let's start with the basics, because this thing is stranger than most people realize. We are talking about a black hole. Not just any black hole either. This is a supermassive black hole, and it lives at the very center of nearly every galaxy in the universe, including our own Milky Way. Here's what makes this so strange. A black hole does not glow. It does not shine. It swallows light instead of giving it off. So how do we even know it's there? Think about it like this. You cannot see the wind, right? When scientists finally measured how heavy that invisible thing must be, the numbers were almost too big to believe. We are talking about objects that pack the mass of 1 million or even 1 billion suns into a space smaller than our solar system. Now here is the part that should really mess with your head. Even though these black holes are unbelievably heavy, they are actually tiny compared to the galaxy around them. If you shrank an entire galaxy down to the size of a grain of sand, the black hole at its center would be smaller than a single atom. A tiny speck controlling the fate of trillions of stars. That contradiction, something so small holding so much power, is exactly why scientists have spent decades trying to understand these things. And what they have found recently is turning old ideas completely upside down. We will get into that shocking twist in a minute. But first, if you are the kind of person who likes learning the truth behind the biggest mysteries in space, hit that subscribe button now. This channel breaks down real science in a way that actually makes sense. No confusing jargon, no boring lectures, just the good stuff explained clearly. You will not want to miss what comes next. Not a hole at all. Before we go further, we need to fix a big misunderstanding. Black holes are terribly named, and that name has been tricking people for decades. When most people hear black hole, they picture an empty gap in space, a void, nothing. But that is exactly backwards. A black hole is not empty at all. It is the opposite of empty. It is packed with more matter crammed into a smaller space than anything else we know of in the universe. A better name might be a dark star, because that is closer to what is actually going on. Here is how one forms. Take a giant star, way bigger than our Sun. That star spends its whole life burning fuel, turning simple elements into heavier ones through a process happening deep in its core. Eventually it runs out of fuel. When that happens, there's nothing left to push back against gravity, so gravity wins. The star collapses in on itself in a massive explosion, and whatever is left of its core gets crushed down smaller and smaller and smaller until it disappears from view entirely. The crushed leftover is the black hole. It is not nothing. It is everything that used to make up that star, just squeezed into an unbelievably tiny space. Once it forms, a black hole only really has a few properties left. How heavy it is, how fast it spins. That is basically it. All the details about what it used to be made of, gone, erased. Locked away forever behind a boundary called the event horizon, which is basically the point of no return. Cross that line, and not even light can escape. So when we say a black hole is black, we do not mean it is empty space. We mean it is hiding a mountain of matter that light itself cannot get out of. Now that explains a normal black hole, but supermassive black holes are a different beast entirely. They did not form from just one star collapsing. Something much bigger is going on. And to understand that, we need to look at how these giants and their galaxies grow up together. Growing up together. Here is something scientists have noticed that seems almost too neat to be a coincidence. The heavier a galaxy is, the heavier its black hole tends to be too. It is like they are linked by an invisible leash. Weigh the stars in the middle of a galaxy, and you can make a pretty good guess at how big the black hole hiding in its center is. Scientists call this a correlation, and it is one of the tightest patterns found anywhere in space. For a long time, the leading explanation was collisions. Not collisions between stars, though. Space is so mind-bogglingly huge that when two galaxies crash into each other, the stars almost never actually hit one another. The nearest star to our own sun is over 4 light-years away. That is an ocean of empty space between every star. What actually happens during a galaxy collision is more like a shuffle. Everything gets scrambled. Stars that were once cruising along in neat, calm orbits suddenly get yanked into chaos. Some of that disturbed material gets shoved toward the very center of the newly combined galaxy. And whatever tumbles close enough eventually gets swallowed by the black hole there, helping it grow heavier. If both galaxies had a black hole of their own, sometimes those two black holes even merge into one, becoming something far more massive than either one was alone. For decades, this was the tidy explanation. Galaxies smashed together, the mess feeds the black hole, and that is how you end up with these tight matching sizes between galaxy and black hole. It made sense. It fit the data. Case closed, right? Except one scientist decided to test it by looking at galaxies that had never smashed into anything at all. And what she found broke the whole theory wide open. The twist nobody expected. If galaxy collisions were really the main way black holes grow big, then a galaxy that had never collided with anything should have a small light black hole. That was the assumption going in. So researchers went hunting for the purest, most untouched galaxies they could find. Peaceful spiral galaxies, the kind with beautiful curling arms, the kind that looked like they had spent their entire existence quietly spinning in place with nobody bothering them. They measured the black holes at the centers of these peaceful, lonely galaxies, expecting to find something small. Instead, they found monsters. Some of these untouched galaxies had black holes up to 1 billion times heavier than the Sun. That is not supposed to happen if collisions are the only way these things grow. Something else was clearly feeding these black holes, but what? When scientists ran massive computer simulations, building fake universes from scratch just to watch how black holes actually grow inside them, they got an answer that shocked a lot of people. Galaxy collisions were only responsible for feeding black holes maybe 1/3 of the time. In some simulations, it was closer to 1 in 7. That means most of the time, something totally different is doing the heavy lifting. Scientists now think galaxies might have their own internal plumbing system for feeding black holes. Long, straight structures called bars can slice through the middle of a galaxy like a funnel, guiding gas toward the center. The graceful spiral arms themselves might act like slides, gently carrying material inward over millions of years. There is even an idea that galaxies pull in fresh gas from a giant cosmic web that stretches between galaxies across the entire universe, like invisible threads connecting everything. And then space telescopes made things even weirder. When a powerful new space telescope started peering into the deepest, oldest parts of the universe, it found something that should not have been possible. It spotted supermassive black holes that were already fully grown just 800 million years after the universe began. That might sound like a long time, but it is actually a blink of an eye in cosmic terms. There simply should not have been enough time for a normal star to explode, form a small black hole, and then slowly bulk up to 1 million times the mass of the sun that fast. It's like finding a fully grown oak tree the day after you planted the seed. This discovery has scientists rethinking everything. Maybe in the early universe, giant clouds of gas could skip the whole star and explosion step entirely and collapse straight down into a black hole. A shortcut nobody expected. On top of that, the same telescope kept spotting strange little red dots scattered across the deep sky. At first, everyone thought they were baby galaxies growing new black holes. But when scientists studied the light coming from them closely, some had the telltale signature of a feeding black hole and some did not. Nobody agrees yet on exactly what these little red dots really are. One leading idea is that each one might be a black hole wrapped in a thick, hazy cocoon of gas and dust, like a giant used to hiding inside a cloud. So here we are. A monster that seems to defy the simple story we told ourselves for decades, growing faster and earlier than it should, using pathways we are still trying to map out. Which leads to an even bigger question. If these things can just keep growing and growing, is there a limit? And what happens when a black hole gets so big that even its growth process breaks down? How big can it get? You would think a black hole could just keep eating forever, growing bigger without any limit at all. But it turns out there is a ceiling, and the reason why is surprisingly delicate. When material falls toward a black hole, it does not just drop straight in, it spirals in slowly, forming a swirling disk of super-hot gas that glows incredibly bright as it heats up from friction and speed. This glowing disk is actually how we spot most black holes in the first place, since the black hole itself gives off no light at all. We are really seeing the glow of everything about to be swallowed, not the black hole itself. But here is the catch. If you cram too much material into that swirling disk too fast, the pressure builds up so much that it basically explodes outward instead of falling in. Picture blowing up a balloon past its limit. At some point, it does not hold any more air. It bursts. black holes have a similar limit, and when they hit it, they can let out massive bursts of energy and gas, sometimes as wide, fast jets shooting out from the poles like a cosmic sneeze that can stretch for hundreds of thousands of light years. Because of this limit, scientists think there's a maximum size a black hole can reach while still being visible to us, somewhere around 100 billion times the mass of the Sun. Beyond that point, something strange happens. The zone where material can safely orbit shrinks so much that it actually gets swallowed up by the region where gas prefers to clump together and form new stars instead of feeding the black hole. In other words, the black hole basically starves itself out of existence as far as we can see it. It goes dark, not because it stopped existing, but because it can no longer put on the glowing show that lets us find it. That means there could be black holes out there right now, even heavier than the ones we have discovered, quietly hiding in total darkness because they have already grown past the point where they can shine. Now here is a question a lot of people ask. Once they learn all this, what about our own black hole, the one hiding in the middle of the Milky Way? Should we be worried? Right now, our black hole is actually pretty calm. It's not actively feeding much, which might sound disappointing, but it is honestly great news. Some scientists think this quiet behavior might be one of the reasons life was able to survive and evolve on Earth in the first place. If our black hole had gone through one of those violent, bright feeding phases any time in the last few billion years, the burst of radiation could have swept through the galaxy and made things a lot harder for life to hang on. But that calm is not permanent. In about 5 billion years, our galaxy is set to collide with our closest large neighbor, a galaxy called Andromeda. When that happens, everything gets shuffled up again, just like we talked about earlier. Stars will get pulled out of their orbits, gas will come streaming toward the center, and there's a good chance both galaxies' black holes will eventually merge into one truly massive giant, possibly waking up and feeding in a way ours has not done in a very long time. Nobody knows exactly what our night sky or our solar system's fate will look like when that happens, but it is a strange thing to sit with. The same quiet monster sleeping at the heart of our galaxy right now might one day wake up, grow, and reshape everything around it, the same way its cousins have done in galaxies across the universe for billions of years. That is the story of the invisible giants hiding inside every galaxy in the sky, including our own. Small compared to their galaxies, yet powerful enough to shape their fate entirely. If this blew your mind even a little, do us a favor and hit that like button and make sure you are subscribed with notifications turned on so you never miss a video like this one. Now, here's a question for you. If you found out there was a sleeping giant at the center of our galaxy that could one day wake up, would you want to know more about what it could do? Or would you rather it just stayed asleep forever? Let us know in the comments. And if you want to keep exploring the strangest mysteries in space, check out our video where we unpack some of the biggest unanswered questions in the entire universe. You will not want to miss it.